Hey guys, so in this video I'm going to talk a little bit about perfect square trinomials and how to factor them. What's important is you have to be aware of what they look like. So if you have a trinomial in the form of you have a perfect square at the front and a perfect square at the back, then the middle term, if it's of the form of 2 times a times b, then you have a perfect square trinomial, and it's going to always factor to a plus b whole quantity squared. Same thing with if there's a minus and a plus here and here, then it'll be a minus b whole quantity squared. I'm going to do two with you, and then I'm going to show you that it works just the same way with our x method and grouping if this does not appeal to you. So here we go. If you look at your first example, 4x squared plus 12x plus 9, we still ask ourselves those same questions of is there a GCF other than 1? The answer is how many terms? 3. So normally we go to x method and grouping. However, we see 4x squared. 4x squared, that's 2x times 2x. So that's a perfect square. So my a value is going to be 2x. Then I see I've got a 9 at the end here. That times 3. So my b value is 3. The middle term, in order for it to be a perfect square trinomial, has to be 2 times your a value times your b value. Well, 2 times 2 is 4, 4 times 3 is 12, would be 12x. Oh, hey, this is a perfect square trinomial. Since it's a plus plus, I know it's going to factor to become 2x, that's my a value, plus 3, that's my b value, whole quantity squared. Okay, I'm going to show you that in x method again. So we went through our questions, all right? So our x method says, okay, I know I have to put my a times c at the top. So 4x squared times 9 gets me 36x squared. My b term goes at the bottom. That's positive 12x. So since my a times c is positive and so is my b term, I know it's a plus plus. Factors of 36 that add up to 12 are 6 and 6. So now I'm going to rewrite my trinomial as a 4-term polynomial. So I've got 4x squared, and then instead of plus 12x, I'm going to write it as plus 6x, and then I still have that plus 9 at the end. Now I'm factoring by grouping. So first two terms have a GCF of 2x, leaving me with 2x plus 3. My second two terms have a GCF 3, leaving me with 2x plus 3. Notice you have 2x plus 3 and 2x plus 3, so that comes out with a 2x plus 3. Okay, that's the exact same factor. So you have 2x plus 3 whole quantity squared, which is exactly what we got with our PST formula. One more, so our last one, is there a GCF other than 1? No. How many terms? 3. We would normally go to x method and grouping. However, some people can see these right away. X squared is the same as x times x, so my a value is x. My c is 9, or 3 times 3, so my b value is 3. Is my middle term 2 times x times 3? Well, 2 times x times 3 would indeed get that this is a minus there. So since it's a minus sign, we know it's going to be of the form of a minus b whole quantity squared. So my a term was x, my b term was 3, and it's going to be minus. Just to show you that it works with an x method, if I don't always see that pattern, a times c goes up top. So x squared times 9 is 9x squared. Your b term goes in the bottom, and that's negative 6x. So since a times c is positive, we know our signs need to be the same, either plus plus or minus minus. Since our b term is negative, it's got to be minus minus to get there. The factors of 9 that add up to 6 are 3 and 3, or negative 3 and negative 3. So now I'm going to rewrite my trinomial as a 4-term polynomial, x squared minus 3x plus 9. My first two terms have a GCF of x, leaving me with x minus 3. My second two terms, now notice that the leading coefficient's negative. I have to remember to take out a negative GCF, and it's going to be a negative 3, sorry about the bell, leaving us with x minus 3. So now I've got x minus 3 in common for both, so I take it out. And oh hey, what do I have left over? x minus 3. So we know it's really just x minus 3 Hokandi squared, and you can see it either way. So there's perfect square trinomials. If you don't recognize them, just use your x method in grouping and you'll be fine.